Bismillahirrahmanirrahim. Today we will discuss chapter 5, Heart and the Circulation. The circulatory system is a closed network consisting of blood vessels, and the heart. This network supplies tissues in the body with oxygen, nutrients, hormones to cells, and remove the metabolic wastes and carbon dioxide away from the cells. In the center of this system, there is a heart, which is a muscular pump that draws blood in when it relaxes and pushes it out at a great force when it contracts. In every 30 seconds, an average of 5 liters of blood is traveling in the circulatory system to complete one course of circulation around the body. The blood is circulating in the blood vessels that composed of arteries, which carry blood away from the heart, and veins that carry blood back to the heart. Here, in this chapter, the most important physiological points are present in the blood and its structures. So, we will focus on the blood, precisely on the red blood cells, because they possess unique characters, enable them to work as a carrier for many things, like nutrients, hormones, metabolic wastes, and gases, including oxygen and carbon dioxide. In this chapter, we will understand how blood acts as a carrier for oxygen. And in the next chapter, chapter number 6, we will understand how it works as a carrier for carbon dioxide. Let's begin. The surface of the red blood cells is composed of hemoglobin, and each hemoglobin molecule consists of 4 polypeptide chains called globins, and 4 nitrogen-containing disc-shaped organic pigment molecule called hemes. In the center of each heme group, there is a 1 atom of iron, which can combine with 1 molecule of oxygen. And since each hemoglobin molecule consists of 4 heme groups, it can thus combine with 4 molecules of oxygen. Every red blood cell contains about 280 million hemoglobin molecules, so it can carry over 1 billion molecules of oxygen. Normal heme contain iron in the reduced form, which is called ferrous iron. In this form, the iron can share electron and bond with oxygen to form oxyhemoglobin. When oxyhemoglobin dissociates to release oxygen to the tissues, it's called deoxyhemoglobin or reduced hemoglobin. The term oxyhemoglobin is not equivalent to oxidized hemoglobin. Hemoglobin doesn't lose an electron, so it can combine with oxygen. But wait, let's ask 2 important questions. Why oxygen should be dissociated from hemoglobin at the cellular site, and why oxygen should be bonded with hemoglobin at the lung site. Could you explain? In order to understand how oxygen dissociated from hemoglobin upon its arrival to the cell, we have to take a look on the Bohr effect. The Danish physiologist Christian Bohr has described the phenomenon, defined later by his name, as the Bohr effect. He stated that hemoglobin's oxygen-binding affinity is inversely related both to acidity and to the concentration of carbon dioxide. The Bohr effect refers to the shift in the oxygen dissociation curve caused by changes in the concentration of carbon dioxide, or the pH of the environment. Carbon dioxide is one of the cellular metabolic products, and because it is very toxic, it reacts with water to form carbonic acid, which is less toxic. Due to the formation of carbonic acid, the blood pH decreases, which means increase in the acidity, resulting in hemoglobin protein release their load of oxygen. Conversely, a decrease in carbon dioxide provokes an increase in pH, which means low acidity. that result in hemoglobin picking up more oxygen as happen at the lung site. There are some abnormal forms of hemoglobin. The oxidized hemoglobin is called methemoglobin, in which ferrous is converting to ferric state due to oxidation. It lacks the electron that is needed to form a bond with oxygen, so it can't participate in oxygen transport. Carboxyhemoglobin is another abnormal form of hemoglobin. The reduced heme is combined with carbon monoxide instead of oxygen. Since the bond with carbon monoxide is much stronger, 210 times, than the bond with oxygen, carbon monoxide tends to displace oxygen in hemoglobin. It has no odor, so it's called a silent killer. Finally, the role of kidney in hemoglobin production. When the amount of oxygen delivered to the kidney is lower than normal, it releases a hormone called erythropoietin that stimulates the production of red blood cells from the bone marrow, which subsequently increases the level of hemoglobin.